Hey guys, welcome back. Today we'll continue with the book Learn Python the Hard Way, and we will focus on exercise 42, which deals with is A, has A, and the difference of objects and classes. And as always, you can find the link to the exercise in the description below. This is part of the paid section of the book, so you would either need to purchase the book, or alternatively, of course, feel free to follow along with this video. So in the previous exercise, we dealt with classes and objects, and specifically how to use the right terminology and how to use Python classes and objects. And one important difference to understand is the difference between classes and objects. So if we take a look at an example of this question here, what is the difference between a fish and a salmon? That can kind of represent what objects and classes are to each other. If we take a look at this question, a salmon is obviously a type of fish, but both fish and salmon, of course, are fish. So fish refers to the type, sort of, and salmon is a specific instance, specific part of that fish category. So we can think of it as fish would be the overall class, and salmon would be an object, would be an instance of this particular class here. If we take a look at another example, what is the difference between Mary and a salmon? And it says before that there are different salmon called Frank, Joe, and Mary. So Mary itself would be a salmon. So what is the difference between that? Again, we can see that salmon would be the type of fish that we're looking at, and Mary would be one specific instance of that, so one specific object that we're dealing with. And that might be a little bit of a weird example, but that kind of represents or shows what the difference between classes and objects actually is. So in this case, the fish is a class, salmon can be a subclass of that, and Mary would be a specific object, a specific instance of that. So let's take a look at how this could look like in code itself. And specifically, we are going to work with two different catchphrases, is A and has A. So is A would be used when we talk about objects and classes being related to each other by a class relationship, and we will use has A when we talk about objects and classes that are related only because they reference each other. And it will become clearer what the actual difference is if we take a look at that code. So let's go ahead and actually let's create a new Python script in a Python text file and then take a look at these examples here. So let me open up the terminal here, and as always we can navigate to the repository that we created and create a new Python file. I'm using Visual Studio Code, so here I can type in code followed by the name of the Python file. So in this case, exercise 42.py for Python, for instance. And this is going to open a new Python file. And we can get started here at the top with a comment. So here we start off with the is A relationship. So animal is a object or is an object. In this case, that would be the first case. And here we have the class animal. And we just have an empty class basically. So we can see this is a is a relationship, not a has a relationship, because actually it's a particular, if we take a look at that again, particular instance of that. So we would use the phrase is a when we talk about objects and classes being related to each other by a class relationship. So in this case here we have the class animal, which is an object. So that's an is a relationship. So next we have, if we scroll down a little bit, class dog animal. And let's just fix that the class is spelled correctly like this. So we have the class here, and then inside of the class we have an init method which takes two parameters, self and name. And then we assign name to the name variable here associated with the class itself. So if we start here at the top, that is basically, so dog is an animal. That would be an is-a relationship again. And if you take a look at that, we can say self.name has a name. So it's basically a has a relationship. After that, we have another class cat, which inherits from the animal class. And inside of that, we have another init method, which takes self and name, or it has those two parameters here. And then below that, again, we assign name to self.name. So here, that of course again is an is-a relationship. So cat is an animal. That's just the same as we have the case up here. So it's quite identical. And then here we have a has-a relationship. So self.name has a name. Let's continue here. After that, we have, of course, again, another example of a class here. So person is a object. It's an is-a relationship. And technically speaking, we don't need those this entry object here in those parentheses. We learn a bit later this is actually an old syntax that was used in the previous Python version, Python 2, which is not really used anymore, but just for making it more explicit that this is actually well, a class basically. We can add this in here. Next we have an is-a relationship, so self.name, has a is in name. So we assign this. And then we have another has a relationship, so self.pet equals none. We add this in here. After that, another class. So again, we say employee is a person. And we write that as class employee, and then on this parentheses we add person. We have an init function that takes this time has three different parameters, self, name, and salary. And let's just take a look. We call super. We pass in employee, self, and then we call init and pass a name to it. So we call the init function. Let's take a look at that. So that should be, it has a relationship, I believe. Yeah, so employee has a name, I guess. So after that we have self.salary, and we set that equal to salary. So again, we have a has a relationship, so self.salary, salary basically. And now we continue this. Here we have a fish object again. That's just the same as before. So fish is a object. Same for the next case. So salmon is a fish. And that of course as well. So let's just a very similar structure here. Okay, and now we switch over to actually instantiating objects using those classes. So here at first we have Rover is a dog, where we take the class dog, we instantiate it using the Rover string here, which is then being used to assign it as a name, and that is stored back in the object we create, so which we call Rover. And in a similar way we have Satan is a cat. So here we take the cat class, we pass in Satan and save that in the object here at the beginning. And again we have Mary is a person, this kind of relationship. So we call the person class, pass in the string Mary and save that back in the Mary object. So, and then we have a has a relationship because we take Mary, the object, we call pet on it and set that equal to Satan. So we basically associate pet with Satan. So Mary basically has a pet called Satan. After that, we instantiate another object using the employee class this time with a certain salary. So we say Frank is an employee. So you have an is a relationship. After that, we take Frank the object and assign Rover to it as a pet. So we say Frank has a pet called Rover. And then we take Flipper, instantiate it as a fish. So Flipper is a fish, instance of the fish class. After that we have Cruise, instantiate the salmon class here. So Cruise is a salmon. And then finally we instantiate another class and we set that equal to the object Harry. So Harry is a put like this, and we can save that. So that's the difference between is_a, which is mostly used when we talk about classes, or in this case instantiating a new object based on a class, and has_a, which is a different kind of dependency relationship, where we for example set the value for pet equal to another value. And now let's take a closer look at what we saw before here in terms of the object. So here in some of the cases we instantiated another object. So for example, we took the employee class here and we set it as a subclass of the person class, and therefore we basically inherited the attributes set up in the person class, in the parent class. But if we didn't do that, we wrote in object in this case. The question is, why do we have to do that, or do we even have to do that? And actually we don't have to do that anymore in Python 3. That is a syntax that was used in Python 2. In Python 3 it's actually not required. We would typically just leave that empty, but it can make it a little bit more explicit. So we explicitly basically say that we take a class, we create a new class, and then we say we take the object things and then associate that with it. So in Python 2 there was a difference between the two types of classes. Now we don't have to worry about it. So the only tricky part to use object involves the mental gymnastics of saying class name as a class of type object. And therefore in the past that was required. Now we don't have to do it anymore. We just use it here to be more explicit. So let's take a look at the study drills. And the first one is to research why Python added the strange object class and what that means. So if we take over a look at Stack Overflow, for example, and I just found this answer by just searching online. So in Python 2.x, in the previous Python version, when you inherit from object, your class is a new style class that was implemented back in Python 2.2. So the non-inheriting from object case creates an old style class that was actually maintained only for backwards compatibility. So therefore, back in the day, it was required to use this kind of syntax to write class name and then in parentheses object when we didn't inherit from another class, just to make that clear. But now in Python 3, that's not required anymore. We can just write the class name itself. So next, is it possible to use a class like it's an object? And if we research that a little bit more, then we learn that everything in Python is actually an object, including classes. And that means that we can reference classes, passing them around like arguments, store them as attributes, names, lists, dictionaries, etc. So that means, yes, we could do that. We could use a class basically as an object. In fact, everything in Python is an object that we're working with. Now next, we can actually take a look at some of the classes we created, the animals, fish, and people class in this exercise. We can fill them with functions and make them do things. So for example, if we go ahead and we take a look at, let's say, the animal class here, instead of typing in pass, we could, for example, say we want to add an init class, and let's call self on it, and maybe let's take a name. Set the name up here, and then let's say we have a run function. Like this. Now, when we do that, we could go ahead and then use the run functions. So for example, here we have rover. And let's see if that works if we call run on it. And we can go ahead and and we need to make sure to call self. So let's do something different. Instead of calling that on the doc object, let's see if we, or let's do that here at the bottom. We just create a new animal, and we create a new animal, passing in the name some animal, and then we can call run on it. Okay, and now after some trying, we can actually get this to work. So we can add the print statement here, we run, and that will be executed. And of course, we could do the same for some of the other classes, for example, for the doc class or for the employee class, for example, to add additional functionalities. Next, find other people's code and work out all the is-a or has-a relationships. So if we take a look at GitHub again, and we search for Python projects. Here, for example, we can take a look at the TensorFlow repository. And here we have then, for instance, different classes that are defined. So here we have an is-a relationship, for example, that the symbol is a tensor because that is a parent class here. And then, of course, if we have some functions inside of that, we can basically say here the value class has a NumPy method that is defined that can be used. In a similar way, we can work through other types of code, of course, and follow up with the is-a or has-a relationship. Make some new relationships that are listed in dictionaries so you can have has many relationships. Yeah, we could also create not just one attribute, but multiple attributes, and then also reflect that. And finally, do you think there's such a thing as an is-many relationship. Read about multiple inheritance, then avoid it if you can. So there's actually no such thing as an is-many relationship. There's an has-many relationship that we can be using, but that does not exist. And in terms of multiple inheritance, we typically would inherit from one single parent class to use that functionality in our subclass, but multiple inheritance is typically a bad idea. So finally, let's take a look at some common student questions. The first one is, what are these comments here with a question mark comments for? So those are the fill in the blanks comments that we saw up here, where we actually filled in whether it was an is-a or has-a relationship. What is the point of self.pet equals none? That makes sure that self.pet attribute, that the self.pet attribute of that class is set to the default of none, so that we set it to a default value. And then finally, what does super employee self.init name do? So that's how you can run the init method of a parent class reliably. Search for Python 3.6 super and read the various advice on it being evil and good for you. So we can search for that on Google to take a closer look at what this actually does and how we can work with it. So superclass basically allows us to, so let's take just the first hit. So we can use a super function So super alone returns a temporary object of the superclass, parent class, that then allows you to call the superclass method. So we can do that if, for example, we have a certain function that we define in our superclass, here in the parent class, animal, for example, and we want to use that function in one of the subclasses, then we could call super followed by the name of the function that we want to be using from the parent class. So that's it for exercise 42, and see you guys next time in the next video.